Now for a short discussion about how gas laws are used to determine the density of a gas or the molar mass of a gas. This is actually not very complicated, but it's worth a brief discussion. When we're talking about different kinds of properties of gases, sometimes you're going to be asked to determine the density of a gas or its molar mass using things that are measured for gases, things like volume and pressure and numbers of moles or grams. And so we can use these in combination with the ideal gas law, PV equals nRT, to rearrange and come up with density. So let's look at this explanation a little bit of where it arises. Density, as we have seen somewhere, is mass divided by volume. And if you go back to the ideal gas law, volume is, in fact, nRT divided by P, or 1 over volume is the reciprocal of that. So if you put 1 over volume in where we had volume here, you have P over nRT. And so if you put all that together, density, in fact, is going to be the molar mass, because related to the molar mass, because the number of grams divided by the number of moles is always going to be a molar mass. So that's what this capital M here is, times P divided by R and T. So this becomes a very simplistic looking relationship. Density is the pressure times molar mass divided by R and T. It all derives from the molar gas law, our ideal gas law. You can get there other ways, but this is a shortcut if you know this relationship. By the same token, then, you can rearrange that equation, and the molar mass, with a fancy M here, is going to be rearranged from that previous equation to be dRT over P. And so you can, if you know the density of the gas, you can come up with the molar mass of an unknown gas. So two relationships that are kind of shortcuts to calculating characteristics of a gas like density and molar mass. So here's an example of how we might think about this. You might have a bulb for a flask for containing your gas. You weigh it when it's empty. You fill up the gas and fill up the bulb with the gas, and you determine the pressure and the temperature, and you weigh it again. Then once you know the mass and the volume, you can get the density. This allows you then, given pressure and temperature, to calculate a molar mass. And so we can rearrange this equation to get the density, or we can use it to get the molar mass using those relationships already shown. All right, so here's an example. Let's try one. And we'll see if we can guess what the gas might be when we're finished. So there's a vessel of 2.1 liters described to have 4.65 grams of a gas, 1 atmosphere pressure, 27 degrees Celsius. What is the density? What is the molar mass of the gas? Well, we think we have enough information if we remember the equation. The molar mass we're going to determine based on the density times R times T divided by P. We have the pressure here. We have a mass, small m. We have temperature, which of course we're going to have to convert to Kelvin. So let's add 273 here, make it direct. So we don't want to forget Kelvin. So that's going to be 0, looks like 300, doesn't it? 300 Kelvin is our temperature. And make sure you can do those things routinely. But the density then is mass divided by volume. Okay, good. We already have volume, no problem there. And so what do? We put in the grams, we put in the liters. Gas densities are typically described in grams per liter as opposed to milliliters like we've used for solids or liquids perhaps, because they tend to have a very few grams in a large number, in a large volume, and so grams per liter is more logical. And that gives you an answer of 2.21 grams per liter. Once you have the density, then we can come up with the molar mass. So molar mass will be the density times the gas constant times the temperature in Kelvin, and they're using all the sig figs for 273.15. It's appropriate to put them in as you choose, but typically your answers won't be affected hugely if you don't. And so having set this up properly means that some things should cancel, like liters and like Kelvin and like atmospheres. And that, if you've done it all correctly, your units that remain should be the desired units. Grams per mole should give you molar mass, remembering that if you always pay attention to your units, it's a really good clue as to whether things are set up properly. and it gives us a mass of 54.6 grams per mole. Now, chances are you don't have any idea what gas this might be, but that one possible idea is that it could be fluorochlorine, which is kind of a funny name, or fluorine chloride, funny name, FCl, because the molar mass of fluorine is 19, and the molar mass of chlorine is 35.45. Well, it's close to that anyway. And that should get you something around 54. So that's pretty close guesstimate. If the measurements are reasonable, then probably that's your guess. Okay, so that's a couple quick examples of how molar mass and density can be derived from information that we combine with the ideal gas law to make some easy calculations. I hope that is helpful. Good luck on your assignments. See you in class. Ask lots of questions.